Hey guys, Miss Sweeney here. I thought we'd do something a little bit different this week and take a break from our IB papers. And I'm going to share with you one of my favorite classes that I took in college, which is called the History of Mathematics. I thought it would be interesting to share some of my favorite topics from that class with you this week. And I'm going to start with one of the earliest forms of numbers and mathematics that we see in human history, which come from the ancient Egyptians and their hieroglyphic number system. I know many of you asked for some real-life mathematics and college-level mathematics, so this is the best that I got for you. Maybe you can use this one day to go win trivia or Jeopardy. But this is a college-level textbook that I'm going to be working out of, and I hope that it's interesting and you learn something new. So the ancient Egyptians, while they developed the first number system, theirs is not the first time that we see numbers used in human history. The first instance of numbers being used in human history goes back 30,000 BC, where farmers were carving notches, or what come today to be known as tally marks, into bones of their deceased animals. And the reason they did that was to keep track of how many animals they had. While each of these representations here did not have a special name, like 1, 2, 3, 4, 5, and they did not have a special symbol, it was understood that if I saw one notch in the bone, then there should be one sheep in front of me. And similarly, if there were 5 notches in the bone, then there should be 5 sheep in front of me. If there were not, we had a problem. They also carved into bones often to keep track of how much was collected during harvest and simple things like that. Now, if we fast forward to 26,500 years, that is a long time, we end up at the beginnings of ancient Egypt, and we are in the year 3,500 BC. So for over 26,000 years, numbers and math for humans was notches and tally marks. But now people are beginning to arrive in what becomes known as ancient Egypt, and they start developing a city. They develop the hieroglyphic language, which you should all recognize. Here's a picture of it over here to the left. It's picture script, where each character represents a concrete thing in their lives and represents words and writing. Along with this picture language, they also create a number system. Now, you might be asking, why would they develop a number system? We've gone over 20,000 years without one. Why do we need one now? Nobody else has one. And here is my hint for you. Check that out right there. Government's empty hand. Ancient Egypt is one of the first developed and powerful and extensive cities with an administration system, which comes to be known as government today. Well, this administration system wanted to be able to conduct a census. They wanted to be able to maintain an army, and they wanted to get taxes, or collect taxes, I guess I should say. It was before this time, there was no need to have a number system. There was no need for large numbers, but now we have a need for them. We need something beyond tally marks because we're counting such large groups of people, of things. So here is the basics of the hieroglyphic number system. You'll notice here that it is a base 10 system. This is the first time in human history that we see grouping happening. It's not just individual tally marks. We're actually grouping things together. We're grouping numbers together instead of writing a tally mark 1 million times. Why is it a base 10 system? Because you have 10 fingers on your hand. And that's honestly why base 10 system exists. It goes back to the fact that you have, as a human, 10 fingers on your hand. Some other ancient number systems are base 20, which is because you got 10 fingers and 10 toes. And I can talk about some of those in a later video if you guys are interested. So here are our basic base 10 hieroglyphic number system. What in the world are these symbols? Well, this one right here, it's a single tally mark. It goes back to the number system that we've been using for thousands of years. The number 10 and groups of 10 are represented by horseshoes. 100 right here, that's called a curved rope. 100,000, this symbol right here, is a lotus flower. 10,000 and groups of 10,000 are represented by a bent finger. 100,000 is a tadpole. This one is my for 1 million. It's two different variations, but it's described as a person holding up two hands in great astonishment, which just cracks me up. And then for 10 million, we have the rising sun. Where these images came from, how they were decided on, is really up for debate by archaeologists, but here they are, and we're going to work with them. Some special differences to note between our current number system and Egypt's number system. It's a non-positional system. For example, if I write the numbers 1 and 2 together, you know that that's the number 12. However, if I write 2 and 1, that is the number 21. The position of numbers in our system matters. In the Egyptian number system, well, 12 would be a 10 and 2 tally marks. This is 10 and this is 2, which makes 12. Whoops, wow, 12. However, I could also write it as 2 and 10. This is still 2 and this is still 10, which still makes 12. It's a non-positional system. Where the symbols are written and in what order they're written doesn't matter. If I wanted to write 21, I would need 2 10s and 1 tally mark. I could also write it as 1 tally mark and 2 10s. They also often, to save space, will group numbers together or stack numbers, which I'll show you here in a couple examples. So our first example is to figure out what number this is. So I see that we start off with 6 tally marks, which is the number 6. Here we've got 3 horseshoes, and each of those are the number 10, which means that's 30. We've got 1 curved rope, which is 100. We've got 2 lotus flowers. Each lotus flower is 1,000, which means this is 2,000. We've got 4 bent fingers. Each of those is 10,000, so if we have 4 of those, that would be 40,000. And 1 tadpole, which is 100,000. So, adding each of these things together, 6 plus 30 plus 100 plus 2,000 plus 40,000 plus 100,000 gives us 142,136. So you can see why they do have a well-developed number system here. It's not the most effective way of writing this number out. Much quicker than drawing that many tally marks, though. So next example, we're going to express 70,807 in hieroglyphics. Different ways to approach this because, again, number order doesn't matter, but I'm going to start from right to left. So I see that we have the number 7, which means that I need 7 tally marks. 1, 2, 3, 4, 5, 6, 7. And again, to save room, they would stack. So I'm stacking 4 on top of 3, but that's 7 there. We have no numbers in the 10 space, which means I don't need any horseshoes. We do have 800, which means that I need 8 curved ropes. 1, 2, 3, 4, 5, 6, 7, 8. And we've got no thousands, so no lotus flowers, but we do have 7 10,000s, which means I need 7 bent fingers. 1, 2, 3, 4, 5, 6, 7. So there is the number 70,807 written in hieroglyphics. We could reverse all of these and put this first, this second, this third. The order in which these groups are presented doesn't matter. And our last example, gonna do some math in hieroglyphics. We're going to add together this number, plus this number. So you can work with just symbols, or I'm going to convert each of these groups of symbols into the actual numbers, add those numbers together, and then represent them as hieroglyphics. So in this first group here, I see that we have 4, 5, 6, 7 ones. We have 1 lotus flower, so that would be 1,000. And we've got 6 bent fingers, so that's 60,000. So this first number is 61,007. And to that, we are going to add, well, over here I see that we've got 5 ones, 1 10, 2 hundreds, and 5 bent fingers. That's 10,000, so 5 10,000s is 50,000. So that gives me the number 50,215. If I add those together, I end up with 111,222. So I'm going to write that. So that's what happens when we add those together, and I'm going to quickly write that in hieroglyphics. So we've got 2, we've got 20, which are 2 horseshoes. We've got 200, so that's going to be 2 curved ropes. We've got 1,000, excuse me, which is 1 lotus flower. We've got a 10,000, which is 1 bent finger, and we've got 100,000, which is a tadpole, or my best attempt. Well, I hope you had fun with this. There's a 20-point assignment posted on ManageBack for you due Friday where you can practice writing and doing math and some hieroglyphics. I hope that you guys enjoyed this and enjoy a little bit of a break. I'm trying my best to keep you entertained. I miss you guys. I hope you have a great rest of your day. Please, please, please reach out for me if you need any help with this, have any questions, or just need to talk. I'm here for you. Bye, guys.